Hello, Tensor friends. Several of my subscribers have asked me questions about this, and I ask myself the question: do you need to study differential geometry to understand general relativity? Now, in general, studying any advanced mathematics can't hurt you. It can only help in the long range. But if you're time limited and capacity limited, as I am, you really got to be very choosy about what you study. Okay, so the short answer to this, in my humble opinion, is yes, but not all of it. Okay, differential geometry is a large field of study, and if you to oversimplify it, at its core, it's the study of curved surfaces, manifolds on which the calculus can be performed. Now, there's a book I was interested in, and I was perusing it online, and the opening few paragraphs were this: if you've just completed an introductory course on differential geometry, you may be wondering where the geometry went. In most people's experience, geometry is concerned with properties such as distances, lengths, angles, areas, volumes, and curvature. These concepts, however, are barely mentioned in typical beginning graduate courses in differential geometry. Instead, such courses are concerned with smooth structures, flows, tensors, and differential forms. These is the paragraphs of Riemannian manifolds and Introduction to Curvature by John Lee. Okay, so this is the field. So differential geometry is the parent, and this is a sub part of differential geometry, Riemannian geometry. Okay, so it's a branch of differential geometry that studies manifolds that have a metric, as in the metric tensor. This, in my opinion, if you're limited in time and capacity, this is the branch of Riemannian geometry you need to understand. Let's take a look just as an example of what differential geometry is. Okay, based on the research that I've done on this subject, and I have studied it a little bit, this is an example of introduction to differential geometry. This channel is called Tensor the Calculus by Robert Davey. He has 44 of the videos of this, okay? And he starts at what is a one form, okay? And he goes on and on and on and on. There's some good stuff in here, by the way. If you're interested in differential geometry, this really is a good place to start. It doesn't cover the whole field, obviously, because it's an enormous the field. It really is large. But this is a good introduction, okay? Okay, but if you're interested in general relativity, as I am, right? The language of Riemannian geometry is tensor calculus. All right, so you want to study general relativity. This is where you start. Tensor calculus. You start here and work your way up. And let's take a look at what that is. Okay, this is my favorite tensor calculus, the channel on YouTube. It's just called Tensor Calculus. It's by Professor Jim Fowler, and he starts literally at the beginning. There's 100 videos here, and I've mentioned this many, many times. The reason I keep bringing it up is because it's really, really good, and it goes on and on and on and on. It is a very, very good channel if you want to learn tensor calculus, uh, and you have a already completed undergraduate calculus the courses. It would be helpful if you've had vector calculus, but it isn't mandatory. It would be helpful if you've had a little bit of linear algebra, but it isn't mandatory. But calculus is mandatory. You really have to have had calculus to do this. Okay? So that's my 2 cents worth. So if you want to study differential geometry, it can't hurt you, but you really need to understand Riemannian geometry. That's the ticket. All right, see you later.